Look at this beam of light shining in a complete void. This is how a frontier AI model operates without external context. It possesses immense reasoning power, yet it exists in total isolation. These models have reached a level of logic where they can solve complex puzzles and write code, but because they lack specific information about your world, they still produce answers that are confidently, spectacularly wrong. Think about the last time you asked an AI assistant to prepare a briefing for a client meeting. You need the history, the current issues, and the goals for the conversation. On the left side of this comparison, you see the result of a model working in a vacuum. It delivers a beautifully formatted template that is completely generic, full of placeholders where the actual data should be. Now, look at a system fed with context. It identifies the specific client, pulls in their recent support tickets, and flags that a contract renewal is coming up. The reasoning is the same, but the output is actually useful. Connecting a raw model to this level of reality requires a structured data pipeline. Without this architecture, the AI produces only a generic shell, leaving the user to manually search for the specific details the system was meant to provide. We call this architecture context engineering. It is the design of systems that allow an AI to discover the right data, understand its meaning, and apply it accurately within a specific environment. Building this system requires 4 pillars to ground the model. The first is connected access. Data is often scattered across databases, clouds, and APIs. Using zero-copy federation, the AI queries the information directly where it resides, instead of moving it. This ensures the AI is always working with the freshest data, while maintaining the original security and access controls of the source system. But access isn't enough. Raw information lacks meaning or a way for AI to understand how files relate. The second pillar, the knowledge layer, maps out relationships and hierarchies to turn scattered files into an organized network. It is tempting to think that giving an AI more data always leads to a better answer. In reality, too much information creates noise that can confuse the model. Pillar 3 is precision retrieval. As you see here, the system filters out the vast majority of data points, focusing only on the documents that match the user's intent, role, and current task. Precision retrieval acts as a filter, protecting the model's limited focus so it can concentrate on the specific facts required to solve the problem. The fourth pillar is runtime governance. This layer ensures every piece of data the AI retrieves is permitted by the organization's security policies in real time. If a user asks for a summary of a meeting they weren't authorized to attend, the governance layer blocks that specific data from reaching the model. Once this foundation is in place, we can move toward more active systems, like agentic RAG. Here, the AI can evaluate its own search results and decide to go back for more information if the initial context is insufficient. With GraphRAG, instead of just looking for similar words, the system navigates these connections to find related entities, like identifying projects associated with a client. These frameworks turn the AI into an active investigator, building its own contextual understanding of a problem before it ever generates an answer. When these 4 pillars operate together, they create a continuous, curated stream of reality that feeds directly into the AI's reasoning engine. Before the final step, context compression summarizes long documents and prioritizes the most vital signals, ensuring the model isn't bogged down by irrelevant details. The result is what you see here, an AI that effortlessly integrates diverse data points, from support history to live contract details, to produce a briefing that is actually ready for your meeting. Reasoning power is a necessary foundation, but it is not sufficient on its own. For an AI to be useful in an enterprise setting, its logic must be applied to high-quality context, making the architecture that feeds the model just as critical as the model itself.